right, welcome back. We're going to today use a tangent line to approximate the value of the fourth root of 18. So this is called tangent line approximations, or it could be called local linear approximations. If you think about that phrase, local linear and tangent line, they're pretty much equivalent. I like local linear approximations because here's the deal. We're going to take a function and we're going to try to approximate the value, say, here. But we're going to use a tangent line to do that, which is a line. So that's why it's called a linear approximation. Let me find my line. So here's, say that's the tangent line. It's not a good one, but I'll make it good. So we're going to draw a tangent line to this graph at a point we know. And you'll see what I mean by that in a minute. And then use the value of the tangent line to approximate the value of the point in question. So we're going to draw the tangent line very near this point, maybe not at this point because we don't know what the point necessarily is, and then compare the values of the tangent lines and the actual function. So if you really zoomed in on this, this is what I'm talking about. And that's the whole idea. We are zooming in on it because we're going to get very, very close. So again, say this is the point right here that I'm approximating, and I drew a tangent line right locally near it. The value of that tangent line here, which should be very close to the value of that point. So that's confusing right there. So let's do it, and I'll show you on Desmos what we're doing. So if we want to approximate the value of the fourth root of 18, we need to draw a tangent line to the fourth root of x because we're trying to approximate the fourth root of something. So let's call it x. So whatever this function looks like, we're going to draw a tangent line to the graph at a point close to 18. Now here's the deal. You can use any point close to 18, but the purpose of this type of problem is to be able to do this without a calculator. So we need to find a point that we can deal with on this function. In other words, use a point that we know what the fourth root of is. So like we know the fourth root of 1 is 1. That would be fine, except it's not close to 18. So the next fourth root would be 16 because 2 to the fourth is 16. And that's a perfect point because that's very close to 18. So to do this, we're going to find the equation of the tangent line. Two y at c equals 16. So we've been doing this very often. That's y minus f of 16 equals f prime of 16 times x minus 16. F of 16 is easy, and that's the point. That's why we chose 16. We chose 16 because we know a lot about the function at 16. The fourth root of 16 is 2. And we should also be able to easily find the derivative at 16. So let's do that up here. The derivative is 1/4 x to the negative 3/4. So I'm going to get rid of my negative exponent, and I'm going to evaluate this at 16. It looks more difficult than it is because remember exponents, the 3/4 means the fourth root of 16 cubed in whichever order you want. Makes sense to do the fourth root first because you don't want to do 16 cubed, obviously. So fourth root of 16 is 2, and 2 cubed is 8. So really what we have down here is 1 over 4 times 8, which is easy. It's 1 over 32. So that's it. That's our tangent line. So the idea here is, since 16 is very close to 18, if I plug in 18 to the tangent line, I will get a value that's very close to the fourth root of x. So here's the equation of my tangent line. Y of 18 should be very close to this y of 18, or the fourth root of 18. So let's do it. Y of 18 would be, you plug in 18 for x. So we have 1 over 32 times 2. That's going to be 1 over 16. 1 over 16 is 0.0625. You can do that without a calculator, but it's just long division. But really the point here is you can do this without a calculator. So we have just approximated the cube root of 18, I'm sorry, the fourth root of 18 to be approximately 2.0625, and it should be very close. And we did this without a calculator, theoretically. So that's how you do it. Now, if you are looking to see what that really actually means, or to clarify, I'm going to use Desmos if I can find it. Here it is. So what I did here in Desmos, oh, there I am. What I did here in Desmos is I graphed the fourth root of x, and I'm going to figure out what the point is at 18, what the value is at 18. So I Desmos do that for me, and the actual value is 18, or is 2.06. Now that's rounded, obviously, because the fourth root of 18 is irrational. So what we did here is we came up with an equation of a tangent line at 16, which is right here. And we got this equation over here. I'm going to turn it on. It's that tangent line. Now the tangent line isn't very close over here to the graph, nor is it very close over here. But at close to 16, which is right here, the tangent line is very close. 16 is right here. The tangent line is very close to the function. As a matter of fact, you can't really tell them apart. You'd have to zoom very, very much. So what we did was we took our tangent line and figured out what the value was at 18. I'm going to turn that on right now. It's going to show you the point. It's right there. So those points are very close. Thus, that's a very, very good approximation. I want to zoom in a little just to show you. Zooming in. I mean, we have to zoom very, very close. Now, I like how the decimals are getting, they're expanding the decimals. So remember, the red is the tangent line. The green is the tangent line. The red is the original graph. And you can see how close they actually are. So that's the whole concept behind this. It's a little bit confusing at first, but if you really think about it, and that's what I want you to do, think about it, it's going to make a lot of sense, I hope. So that's it for that video. Thanks for watching. See you next time.